morning, everybody. I am Dr. S.S. Naidu, Assistant Professor in Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, we are going to discuss very important topic in probability and statistics. It is a very important point, mathematical expectation. What is mathematical expectation? See, whatever random experiment that you may do, the ultimate result is some average value. That average value always gives a concrete idea about what experiment that you are going to do. So it is very important to have an average value of any data. It to maintain the actual occurrence of that event. That's why we use the word expectation. Actually, mathematical expectation, either this directly or indirectly, it relates to mathematical expectation. So this expectation, it directly or indirectly, it leads to average. That's why average is same as mathematical expectation. So what is the significance to find average? To find by finding average of the given data, we will have a concrete idea about that given data, and what will be the probable occurrence which is going to be happened in that system. That is the main significance of mathematical expectance. So this mathematical expectance gives the same idea of average of the given data. So suppose we are taking, we are rolling a die. Then we are rolling the die again for some time. So means what? We are expecting some number to occur there. So in general, what that number that you are unknown person, but what that number that we are going to come out is not known to us, but we are going to estimate. We are going to find out that what number that we are going to thinking to come out. That can be estimated by systematically by our mathematical expectation theory. So suppose you are thinking that some number has to come out while rolling a die again. You are rolling that die to come up to what number that you are going to expect. That number up to come, it comes out. You are rolling it out again. Then what that number that you are estimating, what that number that you are going to bring it out, that we can mathematically, systematically, we can think it out by taking its expectation or average. Here, suppose while we are rolling a die, what are the numbers that may come out? What are the outcomes? 1, 2, 3, 4, 5, 6. So among these 6 numbers, every number has a equal probability. Coming 1 by 6. Coming 2, 1 by 6. Coming 3, 1 by 6. Coming 4, 1 by 6. Its probability. Coming 5, 1 by 6. Coming 6, 1 by 6. All these 6 numbers have the same probability, 1 by 6. That's why we can estimate that the what number that you are going to bring it out or come out, that can be estimated by using its expectation or average. What is the average of all these numbers? 1 plus 2 plus 3 plus 4 plus 5 plus 6. It is 21. You divide this number with the number of numbers. Here how many numbers are there? 6 numbers are there. So sum of the numbers by number of the numbers. It gives us expectation. So here sum of the numbers is 21 and number of the numbers is 6. 21 by 6 is 3.5. Means nearly on an average that what you are expecting is very nearer to 3 and 4. Like that, by our systematic theory, we can expect not only, this is only one example for this event, rolling a die, like that flipping a coin. So many experiments are there, random experiments are there. So for anything, for unknown activity, for unknown event, we can estimate systematically, mathematically using our expectation. Now, let us see some more definitions of this mathematical expectation. See, there are many different uses of mathematical expectation in statistics as well as in so many fields. Now, in this lesson, we are going to learn about the mathematical expectations in random variables as well. So, mathematical expectations are somewhat of a vague concept. This concept is also known as the law of large numbers. So, simply put, this states that a sum of many independent random events will be close to its expected value. So, in other words, if you were to roll a die over and over again, as we discussed earlier, the average or expected value would be 3.5. Of it came also we have discussed. This is because each time you roll the die, there is an equal chance for it to come up with any number from 1 through 6. Now, let us see mathematical expectations in our statistics. Mathematical expectations in statistics, also known as statistical expectations, is a probability that a random variable will take on a particular value. The expectation of an event's outcome is determined by its prior probability and future outcomes. In addition to these two factors, there are also other aspects such as the mean and variance of an event. So, by knowing the value of expectation means by knowing the value of average, we can find other statistical tendencies like mean, median, mode, variance, standard deviation, everything using our standard procedure. So, the mathematical expectation in statistics refers to how likely it is that a given event will occur based on what has happened before and what may happen after it occurs. For example, if you have played poker for years with only losing money each time you play, then your chances of winning at poker are very low because of this history. Because this your history is showing like this, losing every time. However, if you were to start playing again tomorrow and won every game, then your odds would be much better because your history has changed now. Now they will believe you. They will keep confidence on you. Okay, If we believe him, we can win. So that type of confidence comes from our previous history. The mathematical expectation in this case would be that you will win the next game, as it is much more likely given your recent winning streak, as we discussed earlier. So mathematical expectation, also known as the expected value, it is known as expected, what you are going to expect, what you are expecting there. It is the expectation, which is the summation of all possible values from a random variable. It is also known as the product of the probability of an event occurring, denoted by P of x, and the value corresponding with the actually observed occurrence of the event. So, by knowing the observations clearly, we can immediately calculate its expectation. For a random variable, expected value is a useful property. E of x is the expected value and can be computed by the summation of the several distinct values, that is the random variable. The mathematical expectation is denoted by the formula E of x is equal to sigma x1 p1 comma x2 p2 comma etc xn pn, where x is a random variable with the probability function f of x. P is the probability of the occurrence and n is the number of all possible values. So the mathematical expectation of an indicator variable can be 0 if there is no occurrence of an event A. It is clear. And the mathematical expectation of an indicator variable can be 1 if there is an occurrence of an event A. For example, a dice is thrown. The set of possible outcomes is set 1, 2, 3, 4, 5, 6. And each of this outcome has the same probability 1 by 6. Thus, the expected value of the experiment will be sum of the values by number of the values. Sum of the values is 1 plus 2 plus 3 plus 4 plus 5 plus 6 divided by number of values 6. It is 21 by 6. It is 3.5. Means you are going to expect come out 3 or 4. So it is important to know that expected value is not the same as most probable value. It is different. It is not necessary that it will be one of the probable values. So by this we should come to know what we are going to estimate, what we are going to expect. So our expectation is there systematically and mathematically, and it gives the most probable value, the most occurrence value, very nearer to our, as usual, our actual estimation, actual expectation. That is the significance of this theory. Now let us see some properties of expectation. If x and y are the two variables, then the mathematical expectation of the sum of the two variables is equal to the sum of the mathematical expectation of x and the mathematical expectation of y. That is, expectation of x plus y is equal to e of x plus e of y. So, yeah, that summation is equal to sum of the individual expectations. E of x plus y is equal to e of x plus e of y. Expectation of x plus expectation of y. That is the property, first property. Now let us see the mathematical expectation of the product. Also say of the two random variables will be the product of the mathematical expectation of those two individual variables. But the condition is that the two variables are independent in nature. One should not depend on others. They should be individually independent. Then only these properties hold good. In other words, the mathematical expectation of the product of the n number of independent random variables is equal to the product of the mathematical expectation of the n independent random variables. So this is expectation of xy is equal to expectation of x into expectation of y. Means expectation of the product is equal to product of the individual expectations e of x into e of y. Now let us see third property. The mathematical expectation of the sum of a constant and the function of a random variable is equal to the sum of the constant and the mathematical expectation of the function of that random variable, like this. Expectation of a plus f of x is equal to a plus expectation of f of x, where a is a constant and f of x is the function. The mathematical expectation of the sum of product between a constant and function of a random variable and the other constant is equal to the sum of the product of the constant and the mathematical expectation of the function of that random variable and the other constant. This can be shown like this. Expectation of some a into x plus b is equal to, take a outside constant, a into expectation of x plus b, where a comma b are constants. So the mathematical expectation of a linear combination of the random variables and constant is equal to the sum of the product of n constant and the mathematical expectation of the n number of variables. That we can see like this. Expectation of sigma a1 x1, sigma expectation of sigma ai xi in general is equal to sigma ai into e of xi. How can we write this? This can be written as a into a1 into e of x1 plus a2 into a2 into e of x2 plus etc. an into e of xn. So and and so on. See, if I is equal to 1 to n up to here it comes, it goes, then it goes to infinity. So here ai or ak, whatever you may take, ai, that stand for 1, 2, 3, 4, 5, etc. n. They are constants. So the mathematical expectation of a linear combination of the random variables and constant is equal to the sum of the product of n constant and the mathematical expectation of the n number of variables. That is also same like this. Expectation of sigma a xi is equal to sigma a into e of xi, where a I is equal to 1 to n are constants. Now let us see very important topic in this weighted average. What is weighted averages? The notion of simple average was routinely used in Indian planetary models where each planet had a mean motion and a deviation from it. Unlike Western planetary models, there was no belief in any divine harmony, nor any faith in divine laws of any sort involved here. Just an average motion and deviations from it in a down to earth empirical sense. While the deviations from the mean were not regarded as necessarily mechanically explicable, neither were they regarded as quite random, for it was believed that the deviation could be calculated in principle, at least to a good degree of approximation. That is the significance of expectation, mathematical expectation. Now let us see their properties and some assumptions. The first property is that if x and y are the two random variables, then the mathematical expectation of the sum of the two variables is equal to the sum of the mathematical expectation of x and the mathematical expectation of y, provided that the mathematical expectation exists. In other words, e of x plus y is equal to e of x plus e of y. The second property is that the mathematical expectation of the product of the two random variables will be the product of the mathematical expectation of those two variables, provided that the two variables are independent in nature. In other words, e of xy is equal to e of x into e of y. So in these first two properties, what we are going to learn, the expectation of sum is equal to the sum of their individual expectations. E of x plus y is equal to e of x plus e of y. What is the second property? The product of two variables, the expectation of two variables means e of xy is equal to product of their individual expectations, means e of x into e of y. What does the third property say? The third property states that the mathematical expectation of the product of a constant and the function of a random variable is equal to the product of the constant and the mathematical expectation of the function of that random variable, provided that their mathematical expectation exists. The third also states that the mathematical expectation of the sum of a constant and the function of a random variable is equal to the sum of the constant and the mathematical expectation of the function of that random variable, provided that their mathematical expectation exists. In other words, expectation of a into f of x is equal to, take a constant outside, a into expectation of f of x, and expectation of a plus e of f of x is equal to a, take a outside, a plus expectation of f of x, where a is a constant and f of x is the function. The fourth property states that the mathematical expectation of the sum of the product between a constant and the function of a random variable and the other constant is equal to the sum of the product between the constant and the mathematical expectation of the function of that random variable and the other constant, provided that their mathematical expectation exists. So, in other words, expectation of ax plus b is equal to a into expectation of x plus b, where a and b are constants. The fifth property states that the mathematical expectation of the linear combination of the random variables is equal to the sum of the product between the n constant and the mathematical expectation of the n number of variables. In other words, expectation of sigma a xi is equal to sigma a into expectation of xi, where I stands from 1 to n are constants. So in all these things, what we are doing, constant term we are bringing it out, we are keeping it separate. That is holding good in these 5 rules. Now let us see some very important applications of mathematical expectations. There are many different applications of mathematical expectation, such as ranking. For example, in sports, how do you give rank? The expected value is used here to rank the possible outcomes of a game before it even happens. So, the expected value plays a key role, important role here to give the rank for that event, for that game. Next, this can also be used as an approach to value any asset that has multiple possible outcomes, such as real estate or futures contracts. There is a much significance of mathematical expectation here. In real estate, suppose that that person who is doing real estate, he has to come to a certain idea for average value. Why? It is an estimation value, expected value. If he doesn't know properly that expectation value or estimation value, there is 100% probability, 100% scope that his business will go to loss. That's why we should calculate, you should have fundamental idea of mathematical expectation. Because it is a financial matter. If he doesn't know up to which margin he has to sell each flat, definitely he will go bankrupt and entire his kingdom of business collapse. That's why this can also be used as an approach to value any asset that has multiple possible outcomes, such as real estate or future contracts. Pricing and hedging financial derivatives. Pricing and hedging financial derivatives because they represent a random uncertainty in future, cash flows that can be modeled by probability distribution functions. So setting up probabilities in gambling games, very crucial point we are coming now. Setting up probabilities in gambling games like roulette and craps, very dangerous game. Gambling, where the mathematical expectation is applied to calculate the casino's advantage over gamblers. So here, who will gain profit here? Casino. Who has much probability to lose? Player, customer. That's why casinos are coming exponentially, because no casino don't expect for loss. They open casino to gain benefit, to gain profit. For that, what will they do? They indirectly cheat the customer. They indirectly cheat the customer by doing some unethical settings in playing gambling games. So those settings will help only casinos only, not the customer. That's why the casinos gain profit and customer gain, and customer lose is money, cash. This is the point known as house hedge. The casinos which are doing the malpractice, the wrong thing, unethical thing, is otherwise known as the house hedge. The house hedge means casinos contraceptive, their unethical setting of gambling games to lose customers. It is called the house hedge. Now let us see mathematical expectations of random variable. The mathematical expectations of a random variable give us a way to calculate the average value of the variable. This can help understand the behavior of the random variable and in making predictions about future values. So, the mathematical expectation of a random variable is found by taking the product of all the possible values of the variable and then dividing by the number of possible values. This gives us an idea of what we can expect the average value of the random variable to be. We can also use this information to help us understand how likely it is for a particular value to occur. The higher the mathematical expectation, the more likely it is that we will see that value come up in our data set. Conversely, the mathematical expectation is low, then we can expect to see that value less often. So, mathematical expectations are one of the basic concepts that one should learn. There are many applications and uses of mathematical expectations as we have discussed earlier. So, till now, we are coming to some idea about the mathematical expectation and what are their properties and how do we use them in our daily life, using the benefits of them. How do these casinos cheat our customers, how they are gaining profits, how these people are losing. All these things are being discussed. So, the mathematical expectation gives us the expected value, what that we are going to expect, what we are going to gain from it. That is, we are going to expect it by our analysis. So, all these properties, once again memorize. Expectation of some of the events E of x plus y is equal to is a individual, some of the individual expectations E of x plus E of y. Like that, second property, expectation of the product E of xy is equal to product of the individual expectations E of x and E of y. Next, third property, expectation of some a plus f of x is equal to a plus expectation of f of x. Like that, one more property, expectation of ax plus b is equal to a into expectation of x plus b. So, one more property, expectation of sigma AAXI is equal to sigma AA into expectation of xi. So, this can be split it as a1 into E of x1 plus a2 into E of x2 plus a3 into E of x3 plus etc. an into E of xn. If it goes to infinity, next we carry over. So, under weighted averages also, we will come to at least to a good degree of approximation to like this. So, all these properties and assumptions gives us a concrete idea about how to calculate expectation for different situations. Once again, let us see applications of mathematical expectations. There are many different applications of mathematical expectation, such as ranking. For example, in sports, expected value is used to rank the possible outcomes of a game before it even happens. Like that, this can also be used as an approach to value any asset that has multiple possible outcomes, such as real estate or futures contracts. So, like that, pricing and hedging financial derivatives, because they represent a random uncertainty in future, cash flows that can be modeled by probability distribution functions. So the main uses are of this probability mathematical expectation. These people, they utilize very nicely casinos advantages over gamblers. This effect is known as the house edge. Here the main gainer will be casino and the loser will be customer. So mathematical expectations are one of the basic concepts that one should learn in elaborately. There are many applications and uses of mathematical expectations as we are discussing now, and further we will discuss the significances and other uses of this mathematical expectation. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.